On Friday in college algebra, we looked at interest in regards to exponential growth. So we're on exponential functions. We looked at compounding interest and continuously compounded interest. So we have a bunch of variables we got to take into account. Usually this involves investing a sum of money that maybe you inherit, and we want to predict how much money you'll have after so many years. So all the variables are defined up here. P is the amount you deposit. R, that's pretty easy. That's your percent. Just change it to decimal. N is tricky. They're going to tell you one of those words there. So like if they say this thing is compounded monthly, that means N is 12. If they say it's compounded annually, that's 1. Quarterly, that's 4. And semi-annually, that's 2. So that's how many times the interest is compounded in 1 year. And then T, of course, is number of years. And A is the final balance. All right, we have 2 formulas. This is for number of times a year. And this is for continuous compounding. I call that the PERT formula. So let's give it a shot. Looks like we are investing $8,000 for 6 years. So that's our principal. T is 6, but we're having to pick between 2 accounts. We have a monthly account and we have a continuous account. And we just need to plug in and see which one gives us the most return, like the highest balance at the end. This monthly one means N is 12, and it looks like it's at 7%. The continuous one, there's not an N. We just use the letter E on the calculator. But it does give us a different interest rate, 0.685. So let's plug in and check. We have $8,000 times 1 plus 0.07 divided by 12 raised to the NT. So raised to the 12 times 6. I need to type that in. Let's do continuous, though, before we change the slide. Still $8,000, but this time we're multiplying it by the exponential function raised to the RT. And that'll give us continuously compounded interest. All right, so we jump to our calculator. I forgot to clear it from earlier. All right, here we go. I'm going to make sure I use parentheses on this first one. Very easy to mess it up. Also, I need a fraction, control divide. Okay, this cursor needs to go outside the parenthesis because we're raising the entire parenthesis to that NT power. So look at the formula right here. Really important that NT goes outside the parenthesis. So it is press the power button to the 12 times 6 years. 12,160.8. I think it's actually 84. Let's look. If you highlight it, because it rounded, and hit enter, yeah, 84. All right, let's try continuous. 8,000 times E, this is a button, it's in red on your screen right now, raised to the RT, 0.0685 times 6. 12,066 point. Let's see if there's more there. I think there is. 0.60. Actually, nothing was there. All right, this is the result. This is your balance. This means you made $4,160.84. This one made $4,066.60. Monthly is better. All right, at minimum, you need to show me it all plugged in and then that other circled part. So I need to see all of that. I need to see the right side too. I need to see all of this. You can show more work than that, but that's the minimum. All right, maybe hit pause and try this next one. I'm gonna go ahead and work it. P is 10,000. R is 0.08. And T is 5. We're doing quarterly, so that's N equals 4. And we're doing continuous. So this is 10,000. All raised to the NT. This one is 10,000 to the RT. All right, let's see which one that wins. 10,000. 1 plus, I need a fraction, 0.08 divided by 4 raised to the 4 times, forgot how many years we're doing, 5 years. 14,859.47. All right, let's try continuous. Looks right. 14,918 and 25 cents. Continuous is better on this one. Was it because they shared the same rate? I bet it was a combination. Shared the same rate, and quarterly compounded just wasn't as many times as monthly. Continuous one. All right. See y'all later. Bye.